Well, this lecture gives you an overview, very brief overview about what marginal effects and partial effects are, terms that are constantly used in econometric literature and other quantitative social science literature. So what is marginal and partial effects? In this case, marginal and partial effects, they are exchangeable. Okay? So the whole concept or statistical construct of marginal effects can be traced to marginalism and marginal revolution. And actually, there's this zoo of marginals, meaning there are a lot of terms floating around associated with marginals, right? We have marginal utility, that is how much pleasure or displeasure or benefit slash loss one receives in the consumption of one unit. Sometimes we say marginal value. So what is marginal value? Marginal value refers to a value arrived at with given particular constraints. Sometimes we talk about marginal change. Marginal change refers to a value that holds true given particular constraints. That is called a marginal value. A change that would be affected as or by a specific loosening or tightening of those constraints is a marginal change. So what really is marginal effect in quantitative analysis? Well, according to a premium econometrician, Jeffrey Woodridge, he gives a definition of marginal effect, which is the effect on the dependent variable or response variable that results from changing an independent variable by a small amount. According to a Stata website, a proprietary software, right? So what is marginal effect? Marginal effect is the derivative or slope of a given function of the covariates and coefficients of the preceding estimation. What really marginal effect is? A marginal effect measures how much the response variable changes in response to an infinitesimal amount of change in the predictor. Okay? A lot of times, controlling for the values of other covariates, okay? Or given the values of other covariates. Okay, again, a marginal effect measures how much the response variable changes in response to an infinitesimal amount of change in the predictor, right? Given the values of other covariates, if any. So let's say here we have this function, y equal to f of x. What is marginal effect? Okay, of x on y. So assuming we only have one covariate. Well, it is equal to this calculus sign, right? So what is that calculus sign equal to? Well, equal to limit of the change in y, that is delta y, over change in x, as delta x approaches 0. That is, as x approximates 0, very, very small amount. That's why we say infinitesimal amount. When the limit, right, when the delta x goes to 0, then it's going to be equivalent of, this thing. Right? Actually, this is partial derivative. Okay? Assuming in a multivariate case. Okay? In a multivariate case. Alternatively, we can define marginal effect as, this is derivative, right? First derivative. Right? Again, a limit. This is we change x by a small amount, let's say h, right? Plug into the function. We calculate this is a new y. Given that x has increased by h amount. This is the original y, okay? When x is equal to x, over what? Delta x, that is the amount of change in x. As that amount of change approaches 0, okay? As that amount approaches 0, then it's going to be equivalent of first derivative. If we're talking about, only one single predictor. If we have multiple predictors, then we're talking about partial derivative. An example. So let's say y equal to 3x squared plus 4. What is, partial derivative? Well, actually turns out to be 6x. This is the marginal effect, we can say, of x on y. And it varies. See that? It varies. It's still a function varying with x. That is at different location with x. The effect is different. Different. In general, if we have a function follows this form, x raised to the power of n, and if we want to calculate its derivative, then simply it is equal to the power becomes the coefficient and reduced by 1 and multiplied by x. So this is all about calculus. And here, this class is not about calculus, or do we have time to go in depth about calculus? So you can check out some literature about calculus to read more about it. But marginal effect and partial effect, in simple terms, measures how much the response variable changes in response to an infinitesimal amount of change in the predictor. And that's actually the first partial derivative in calculus. They're almost equivalent.